All right. Start at 2364. Get the UPAC names of the following compounds. All right, so we have CH3, C, and another CH3. Up here we got our CHO. And here CH2, CH3. All right, so you have to be able to know how to write a CHO. Again, if your carbon doesn't have 4 bonds, your hydrogen 1 and your oxygen 2, you have the wrong answer. So you should write out all the bonds. And so here is the carbon that is of concern. All the other ones already have 4 bonds connected to them. But if you look at this one, it looks like a carbon connected to a hydrogen and a hydrogen connected to an oxygen. That is all wrong. All right, and so you have to know the only way you can get 4 bonds to the carbon, 2 bonds to the oxygen, and 1 bond to the hydrogen is to draw it like that. All right, and so then you will circle the functional group, name the class of compound. All right, and then you're going to name it. And you have to know that aldehydes, you're going to drop the E, you're going to add Al. That's how you name your aldehydes. When you're numbering an aldehyde, it's always, the carbonyl is always carbon number 1. Then you find the longest carbon chain from there. 1, 2, 3, and 4. So that would be butane. Except we're dropping the E of butane and we're adding Al, and that is butanal. You do not ever put a 1 for the aldehydes. They're all 1s. All right, and so, but we see that we have not named the CH3, either one of them, on carbon number 2. And so to name that correctly, you write it 2, 2 dash dimethyl butanal. All right, and so dimethyl butanal is one word. All right, so the next one, if we go to B, to the right of that one, it says CH3, C8, nope, just C, bonded to a CH2, bonded to a CH3. This is to a COOH. And then down here is a CH3. Again, the key is you have to be able to draw a COOH correctly. All right, because if you write it as C bonded to O, bonded to O, bonded to H, this carbon only has 2 bonds. That is not correct. So to write it correctly, this has to be a C double bonded to an O, and then an O and an H. That is the only way to get 4 bonds to the carbon. 2 bonds to your oxygen and 1 bond to your hydrogen. Any structure that doesn't have 4 bonds to carbon, 2 bonds to oxygen, 1 bond to hydrogen is an incorrect structure. All right, so we circle the functional group. That is a carboxylic acid. To name a carboxylic acid, we're going to drop the E, we're going to add oic acid. All right, and just like your aldehydes, you have the longest carbon chain, but you must start with the C double bond O being carbon number 1. So 1, 2, 3, and 4. So it's going to be very similar to the last one. All right, so instead of a butanal, it is a drop the E, add oic acid. This is a butanoic acid. And again, off of carbon 2, you've got 2 methyls. And so you say 2, 2 dash dimethyl butanoic acid. Okay, next one here is a CH3 with a C. Here's a CH3. Down here is CH2, CH3. and then a CO, and then a CH3. All right, and so again, if you are not thinking that you have to make sure you have 4 bonds to every carbon, if you write a line here and here, that's only 2 bonds to carbon. So you have to know what it means to have a CO right here. So that is CH3, CH3, CH2, CH3. The only way to get that to be 4 bonds is that has to be a C double bond O, then to CH3. That is the only way to get that carbon to have 4 bonds. All right, so you circle the functional group, and that is a ketone. To name a ketone, you're going to drop the E. You're going to add one. O-N-E. Longest carbon chain, the smallest number for the C double bond O. So you always number it from the side closest to the C double bond O. That is this side. 1, 2, 3, and we don't go straight across. We go any direction needed to get the longest carbon chain. And in this case, that direction is down for 4 and 5. All right, and so we have a pentane, but we're dropping the E of our 5 carbon chain and adding ONE because we have a ketone. So we have pentanone. Off of carbon 3, we have a methyl and we have another methyl. So that is a 3,3 dash dimethyl. Now with your pentanone, you have to give the number. So that is a 2 pentanone. That is where your ketone C double bond O is at. That is a 3. 3 dimethyl 2 pentanone. I was thinking about the 2 pentanone when I was saying 3. 3 dimethyl 2 pentanone. All right. The next one has CH3. Then a C, CH3 up, CH3 down, CH2, CH3. When it says to circle the functional group, here is one where there is no functional group. There is nothing to circle. That is an alkane. How do you recognize an alkane? Absence of functional groups. There's no functional group. There's no double bond for an alkene, triple bond for an alkyne. And so that is no functional group. That's an alkane. So now you just have to get the longest carbon chain. And in this case, it is just as written, 4 straight across, because we want the lowest numbers for the groups that are substituted for a hydrogen. And in that case, we have a 2 methyl here and another 2 methyl here. So we have a 2, 2 dash dimethyl butane. All right, 2366. Write the structural formula for each of the following. 3-ethyl 1-hexene. So the way I do it, okay, not sure what's going on. Okay, so I have my hexane. So I need my 6 carbons. 1, 2, 3, 4, 5, 6. I don't need 7. I need 6 carbons. 1, 2, 3, 4, 5, 6 carbons. All right, that is a 1-hexene, and so I know that I have a double bond at 1. It is a 3-ethyl, 1, 2, 3. So here I have an ethyl. All right, I always like to use the line stick model, but that's not the answer. When you write the structural formula, you should write in the carbons and hydrogens. So you have you should write on a double bond. I'm going to write it this way: CH2 double bonded to CH, and then you have a CH, and then down here you have your CH2, CH3 for your ethyl, and then you got your CH2, your CH2, and your CH3. All right, and so this is an alkene. This cannot have cis and trans isomers because these are the same. Therefore, no cis trans. All right, so when one side of your carbon-carbon double bond has the same group, you cannot have any cis trans isomers. All right, 1,1,2 triphenyl ethane. So ethane is simply 2 carbons. And now we have a 1,1,2 triphenyl. So now you got a bunch of benzene rings that you have to draw. One, and 2. So you have to draw 3 benzene rings, 2 of them connected to the first carbon, and 1 of them connected to the second carbon. That is your triphenyl ethane. 1-phenyl 2-pentanone. All right, so pentane is a 5, 1, 2, 3, 4, 5 carbons. Off of carbon 2, you've got a ketone, double bond O. Off of carbon number 1, you've got a benzene ring. All right, so that means you need 2 H's here, you need 2 H's here, you need 2 H's here, you need 3 H's here. All right, and so that is the structural formula for 1-phenyl 2-pentanone. Cyclooctanone. So now you got to write a cyclooctanone. So a stop sign is a octagon. So you're drawing an octagon. So you have 8 carbons in a ring. And so this is a cyclooctane. But it doesn't ask for cyclooctane. It asks for cyclooctanone. That means it is a ketone. That means that one of these carbons, doesn't matter which one of these carbons has a double bond O. You can put the double bond O at any of them. The reason why it's not called 1-cyclooctanone is because you can put that double bond O anywhere, it's still 1. So when there's no such thing as a 2, then you are not required to put a 1. All right, 2377. For the following molecular model, where C atoms are black, H atoms are light blue, write the molecular formula. All right, so the molecular formula, you need to know what that means. That just means the total number of carbons. All right, and so if you look at the picture, you've got 1, 2, 3, 4, 5, 6 carbons. And so that is a C6. Now let's write what it says. CH3, and then CH. Oh, more specific here. CH, that goes this way. Double bond, CH, that goes this way. And then CH2, CH2, and CH3. So that's, all right, so it says basically you just got to count the carbons. There are 6 of them. And then you can count the hydrogens. There are 12 of them. All right, I don't count them because I see that I have an alkene and I know I have CnH2n as my molecular formula. So as soon as I count my 6 carbons, I know there has to be 12. You can count them and confirm that, but that has to be the case. Write the condensed structural formula. So condensed structural formula, well, that's what that is. That is the condensed structural formula. and now give the UPAC name. All right, so now you got to find the longest carbon chain of your alkene. So you circle your functional group. This is an alkene. All right, lowest number possible for your alkene. That means start numbering from the side closest to your alkene. That is the left side. And so we have 6 carbons for our molecular formula. And in this case, it is the longest carbon chain, and there's nothing coming off. No carbons coming off of that. All right, and so we have not a hexane, but we have a hexene because it is an alkene. And that is coming off of carbon number 2. And many people will give this name as 2-hexene and go to the next problem. Well, you're not going to get full credit. All right, when you have an alkene, you have to be aware that you're going to have a possibility of cis and trans. All right, and here it is on the picture that the H on the left is up and the H on the right is slanted down. And so this is a trans 2-hexene. All right, 2379. You encounter a hydrocarbon with the name 2-ethyl 3-methyl hexane. So we can draw that. 1, 2, 3, 4, 5, 6 carbons. All right, off of carbon 2, you've got an ethyl. Off of carbon 3, you got a methyl. So these are the questions that I like to ask. Here is a name. Is it the correct name? And of course, the answer is going to be no. And so it's going to give the correct name. All right. So the problem here is they did not give the longest carbon chain. They gave it as 6, a hexane. It is not 6. The longest carbon chain is 7. All right. So that is a very common error, is to name it just going straight across, left to right. No, you have to find the longest carbon chain, whichever way that chain goes. And so this is a heptane. And off of carbon 3, you have a methyl. And off of carbon 4, you have a methyl. So it is a 3,4 dimethyl heptane. All right, 2380. Consider the molecule CH3, CH2, and then CH, and then CH, and then CH3. Write a structural formula of the trans isomer. Right? So you just have to have your double bond. H1 is going up, 1 is going down. And then you write this one has a CH3 and this one has a CH3 and a CH2. All right, so there's your trans isomer. And you know that it can have cis and trans because when you look at the 2 carbons, this side has an H and an ethyl. Those are different. This side has an H and a methyl, and those 2 are different. And so then, yes, you can have cis trans isomer. Write the name from part A. All right, so we now know that it's trans. All right, so it is then the longest carbon chain. Number it closest to the double bond. 1, 2, 3, 4, 5. So you've got a double bond. You have an alkene. And so the name is going to end in ene. And so you have a pentene. So not a pentane, a pentene. You have to give the number for the carbon that starts the double bond. That is a 2-pentene. Again, that is not the correct answer because it told you to draw the trans isomer and you must write the name as a trans 2-pentene. All right, and now we get a reaction. Write the condensed structural formula for the major product of the reaction of the molecule with Br2. So now we're going to add Br2 to this. So we have CH3, CH2, CH, double bond, CH and CH3. and we're going to add Br2. All right, and so you have an alkene, and what you need to know about an alkene, when it does reactions, it will do a addition reaction. We're going to add the bromine to it. So this is going to do an addition reaction. All right, so, and this is a BR-BR. So you're adding the same thing to both sides. It's not the HBr or an H and OH. It is the same thing, and so each side of the double bond each gets a Br. So CH3, CH2, then you got a CH, Br goes here, then you got a CH, and Br goes here, and then you have a CH3. So you did an addition reaction. And so to name this, we number our carbons closest to the substituted group, bromine. So the side closest to the bromine. All right, so now we have a pentane. We don't have a double bond. It is all single bonds. It did the addition reaction. Carbon has 4 bonds. But off of carbon 2 and 3, we have bromine. So we have a 2, 3 dibromo pentane is our product. And of note, we have a chiral carbon here and we have a chiral carbon here. So this question in organic chemistry is a very difficult question because you would need to know in organic chemistry when you get to chapter 8 is that this is trans, and you would have the mechanism and you would know that it is going to add anti. All right, that means that one of the bromine is going to go up, the other bromine is going to go down, and that only matters if you have 2 chiral carbons. All right, and so when you have a trans and an anti, you're going to get an achiral compound. Well, you're going to get meso, but it's not going to be exactly symmetrical. If you had it, so you're going to have one's going to be R and the other's going to be S. Anyway, that's your fun for organic. That's has to have a mechanism, and you will see that it's going to be an anti-addition, and anti and a trans will lead to a meso compound, but in this case, it's not symmetrical. All right, you can disregard all of that talk. All right, 23.81. Give the UPAC name for each of the following. All right, and so you will circle the functional group. You will give the class of compound, aldehyde. And you will know when you're naming this that you're going to drop the E and you're going to add Al. And that has to be carbon number 1. So longest carbon chain, 1, 2, 3, 4, and 5. All right, so you would have a pentane. But you know you have an aldehyde, so you're going to drop the E of pentane and you're going to add Al. You have a pentanal. And then you see off of carbon 3, you have a methyl. Off of carbon 4, you also have a methyl. So you have a 3, 4 dimethyl pentanal. Part B, you've got CH3 to CH, CH2, CH3, to CH2, to COOH. The only way that you can get that to have 4 bonds to carbon is a carboxylic acid. And so you circle your functional group, that is a carboxylic acid. To name a carboxylic acid, you're going to drop the E, you're going to add oic acid. All right, longest carbon chain, but the C double bond O has to be carbon number 1. 1, 2, 3, it doesn't go straight across this time. Again, you got to go the way that has the longest carbon chain. It is not always straight across. All right, so to get the longest carbon chain, you go up, and that's 4 and that's 5. And so you have a pentane, but we're going to drop the E and we're going to add oic acid. And so we have pentanoic acid. All right, but off of carbon number 3, we have a methyl. So the pentanoic acid are these 5 carbons. So when you name pentanoic acid, you've named those 5. But off of carbon 3, we did not name that carbon yet. So that is a 3-methyl. Pentanoic acid. All right, 83. Draw the structural formulas of the following hydrocarbons. Chlorobenzene. All right, so you have to be able to draw benzene. You must know benzene. If you don't know benzene, you can never get chlorobenzene. All right, so it's simply writing benzene instead of one of the hydrogens, you have a chlorine. That is a chlorobenzene. And so that's an aromatic hydrocarbon. All right, so your choices for hydrocarbons, you're going to have your alkanes, your alkenes, your alkynes. You're going to have your aromatic hydrocarbons. Anytime you have a benzene ring, you have an aromatic hydrocarbon. All right, 4-methyl-2-hexene. 1, 2, 3, 4, 5, 6 carbons. All right, so 2-hexene and 4-methyl. 1, 2, 3, 4. Now, the way I drew it as trans. So this is actually trans. All right, it didn't say trans, it didn't say cis. And so when you do your structural formula, you would do it, I don't know how you would do it. You do it either way, I guess, because structural formulas should show that it's cis or trans. All right, so maybe there's 2 answers. So there's the trans, so 1, 2, 3, 4, and then 5, and then 6. And so this would be the cis. All right, so you would have both the trans and the cis. All right, so 1, 2, 3, 4 methyl, 1, 2, 3, 4 methyl. All right, so 4-methyl-2-hexene would come in both a cis and a trans structural formula. Part C, N-octane, CH3, you can be lazy and say CH2 sub 6, CH3, or of course you can write CH2 6 times. All right, so that is simply octane as your 8 carbons in a row. For each answer in A through C, indicate if the molecule is saturated or unsaturated. So if you have a double bond, you're unsaturated. Benzene rings, all right, we draw the circle because that is resonance of the 3 double bonds. So if you wrote it like that, that's fine. You wrote it like that, that's fine. If you write it without anything in the middle, that's wrong. That's chlorobenzene, that's chlorobenzene. This is chlorocyclohexane, not chlorobenzene. All right, so yes, unsaturated. Unsaturated for your benzene. If this were a choice, it is not one, but this one is saturated. There's no double or triple bonds. All right, and so here you have a double bond. It's unsaturated. Here there are no double bonds. It is saturated. So if you have a pi bond, because to make a double bond, you need a sigma and then a pi. If you are doing a triple bond, you need a sigma and you need 2 pi bonds. If you have a pi bond, it is unsaturated. All right, so that's all the homework. So we're going to go through some of the multiple choice questions. Let's see. That's not what I want. That's what I want. All right. All right. So for the first one, you have an alkane. And really, all you need to know is this alkane has 8 carbon atoms. So when you know that the alkane has 8 carbon atoms, let me do this. Oh, maybe it will. Nope. Yep. So when you have 8 carbon atoms, all right, so you know that an alkane has the CnH2n plus 2. And when it tells you that it has 8 carbon atoms, that's C8, and then H, 16 plus 2, is 18. And so your answer for the first one is C8H18. You could actually write out the formula and count all the carbons, but you do not have to. All right, so number 2, how many hydrogen atoms are needed to complete the following structure? All right, so if you have a cyclobutane, all right, each one of these carbons needs 2 H's. And so, again, if you know the cycloalkane is CnH2n, and you have 4 carbons, you have a C4 and an H8, or you can simply count the number of hydrogens needed to give all those carbons 4 bonds. Number 3, a straight chain alkyne. A straight chain alkyne with 8 carbon atoms. All right, so 1, 2, 3, 4, 5, 6, 7, 8. All right, so you have an 8 chain carbon. All right, again, you can count all the H's, or if you know the alkyne is CnH2n minus 2, and they tell you that there are 8 carbons. So now you have C8, and now you've got 16 minus 2, which is 14. Or, of course, you can add the 1 hydrogen here with the 2, 4, 6, 8, 10 there, plus the 3 there, and get 14. You just simply add up the numbers. All right, so number 4 is to name this molecule. All right, and of course, the hardest thing about this one is finding the longest carbon chain. And when it's multiple choice, let's see, longest carbon chain. Well, if it's an octane, you're going to have 2 choices. So you got your 1, 2, 3, 4, 5, 6, and then either way, up or down, 7, 8. So you have your 8. All right, and so then you can name it as a 4-chloro-6-ethyl-5-methyl. All right, so if you go this way, 1, 2, 3, it would be a 3-ethyl, then a 4-methyl, 3-ethyl, 4-methyl, and then a 5-chloro, and then octane. If you go the other way, 1, 2, 3, 4, that would be a 4-chloro, and then a 5-methyl, and then a 6-ethyl. All right, so you go with the way that gives you the lowest number for your first group. All right, and so your halides are just like methyls and ethyls and propyls. They don't have any priorities. All right, and so when you have your first number as the lowest number as a 4 versus your lowest number as a 3, you would go with the lowest number as a 3. And so that is a 5-chloro, 3-ethyl, 2-methyl octane. And that is the correct alphabetical order, C, E, M, for your alphabetical order. All right, isoamyl alcohol, you certainly don't need to know what isoamyl alcohol is. That's why the structure is given to you. So they give you the structure of isoamyl alcohol, and that is CH3 sub 2. and CH, then CH2, then CH2, and then OH. And so you have to be able to draw this in the correct order. Many people will write it like this: CH3, CH3, CH, CH2, CH2OH. Of course, if you know organic chemistry, that is ridiculous, but that is what people will do. If you do this, you are putting 5 bonds to that carbon. All right, it's already got 3, and now you have it connected to that carbon and that carbon. All right, and this carbon only has the 3 bonds. It's got 1 H and then there and there. Again, you have to be mindful that every carbon has to have 4 bonds. All right, so you have your CH3, which is connected to your CH, which has another CH3. So the CH3 sub 2 means that this carbon with an H is bonded to 2 CH3s. Then you have a CH2, then you have a CH2, then you have an OH. Longest carbon chain is 4. You want the lowest number for the carbon that contains the OH. Okay, so this is an alcohol, so we're going to drop the E and add OL. This is connected to a CH2, so more specific, this is a primary alcohol, but to name any alcohol, you drop the E, you add OL. So 4, and so that is butane. We drop the E, we add OL, we have butanol. Lowest number for the carbon with the OH, that is a 1. And then off of carbon 3, we have a methyl. So we have a 3-methyl, 1-butanol. All right, number 6. What is the correct structure for para-dichlorobenzene? All right, and so you can eliminate ones that are not benzene. So this is a 1,4-dichlorocyclohexane. This is a 1,2-dichlorocyclohexane. You cannot name the cyclohexanes as para or ortho. You can only name the benzene rings as the ortho, the meta. I'm not sure what that other second guess here is. Meta. Yep. So they give you all 3. They give you the ortho, they give you the meta, and they give you the para. So you have to know that para means 1,4. And so the 1,4-dichlorocyclobenzene, that is dichlorobenzene, not cyclo, is your benzene. So again, you have to be very aware, because many people will pick C because they'll say, oh, that's para. That is not para because that's not benzene. In order for it to be ortho, which is 1,2, or meta, which is 1,3, or para, which is 1,4, it has to be on a benzene ring. All right, so how many different isomers can we have for the formula C6H4BrCl? And I wrote in there aromatic because otherwise the answer is not given. You can write all kinds of structures that have that formula that do not include a benzene ring. All right, so it has to be an aromatic hydrocarbon. So your C6H4 is here. All right, so that means that you can put your bromine here and then the chlorine here. Also means you can put the bromine here and you can put the chlorine here, which also means you could put the bromine here and the chlorine here. All right, and so you can put it in the ortho, the meta, or the para position. So there are just the 3 different isomers when you have 2 groups coming off of a benzene ring, and that is the ortho, the meta, and the para. All right, so here we want to know about the molecular formulas, if they're isomers. All right, so we write for number 1. All right, so that is, if we do the molecular formulas, You can do it by unsaturations, which means the number of double bonds versus the number of carbons. And so the first one has 1, 2, 3 carbons. So you can see that it is a C3. And then you have your H, 2, 4, 5, 6, H6, and then O3. All right, so when you add them up, C3, H6, O3, yes, C6, C3, H6, O3, yes. So they all have the same molecular formula. So 1 and 2 do not have a different molecular formula. They have the same molecular formula. Molecular formula is just simply the total number of carbons, hydrogens, and oxygens. All right, so 1 and 3 are isomers of each other. So 1 and 3. So are these isomers? Well, if you name it, which would be very difficult to name, well, you would name the group coming off of the O first. So you wouldn't be able to name that group. It is a CH2, CH2OH group. You would name that group. That is the CH2, CH2OH group. I said the same thing. That is the same thing coming off of the O. Then I would have the deprotonated carboxylic acid being a methanoic acid or methanoate. Same thing here. 1 and 3 are exactly the same. So 1 and 3 are not isomers. 1 and 3 are exactly the same, which is the answer to the question, which is E. 1 and 3 are exactly the same. All right. There's only one correct answer. So 2 and 3 have different empirical formulas. Nope, they have the exact same molecular and empirical formula. 1, 2, and 3 are all isomers of each other. No, they are not isomers because 1 and 3 are exactly the same. All right, so I think I worked this one. Well, if it wasn't for this class, it was for the other one. Your C4H10O will have, so the question here is how many ethers? All right, so you have your oxygen. So if you have 4 carbons total, you can put 1 carbon on this side, 3 on that side. Or you can put 2 on this side, and you can put 2 on this side. And some people will stop at that, except this is the propyl group, which also comes as an isopropyl group. So there are 3 isomeric ethers with that formula. All right, so then the next question is about the alcohols. So how many isomeric alcohols are there with that same formula? All right, and that's when you have to know your butyl groups. So you have to know that you have your N-butyl alcohol. You've got your, oops, too many. You've got your sec-butyl alcohol. You've got your tertiary butyl alcohol. And finally, you've got your isobutyl alcohol. All right, so you got your N-butyl, your sec-butyl, your, didn't finish it, tertiary butyl, and your isobutyl alcohol. So there are 4 isomeric alcohols. That is the N-butyl, isobutyl, sec-butyl, T-butyl. Those are your 4 butyl groups. All right, so 11, which of the following compounds are different? Are isomers differing? I can't finish it because I can't see it. In functional groups, all right. All right, so the first one is an alcohol. So number one, alcohol. Number 2, alcohol. Number 3, ether. Number 4, carboxylic acid. Number 5, aldehyde. All right, so which of the following are isomers differing in function? Okay, so now you have to know which ones are isomers. So now you have a 2-carbon alcohol, you have a 3-carbon alcohol. Well, that's the same, that's alcohol, that's alcohol. 1 and 3 are isomers, so they each have 2 carbons, 6 hydrogens, 1 oxygen. So 1 and 3, those are isomers differing in functional group. When we look at 4 and 5, these do not have 6 hydrogens. They only have 4 hydrogens. Both of these have 4 hydrogens. However, this one has 2 oxygens. This one only has 1 oxygen. So the only one that are isomers that differ in functional groups, so isomers mean they have the same number of carbons and oxygens and hydrogens, and that is 1 and 3, because 1 and 3 differ in functional group. You got an alcohol, you got an ether. Number 12, which of the following compounds is an ether? All right, so this one you have to be able to draw the 4 bonds to carbon. So A is CH3, CO, CH3. You have to know in order to get 4 bonds that O is a double bond O, that is a ketone. What in the heck is the second one here? All right, so CH3. And then you got an O, and then you got an O, and then you got a CH3. That is very strange. That is a peroxide. All right, that is not an ether. All right, and so then you have your dimethyl ether. So yes, C is an ether. D, that is an alcohol. And then E is your carboxylic acid. So the only one that is an ether is C. All right, when you have a C double bond O, you have, it is characteristic. All right, so in order to have an acid, that has to have an OH with it. In order for it to be an aldehyde, it has to have an H with it. In order to be a ketone, that's all you need. Yes, that is a ketone. For that to be an ester, it would have to have an OR group with it. In order for it to be an alcohol, you couldn't have a C double bond O. All right. So an acid, an aldehyde, and an ester, they all have C double bond O's, but that one, not given an OH with it, not given an H with it, not given an OR with it, that is a ketone. All right, which one of these is an amide? Well, A is an amide. That is a primary amide. It's NH2. The second one here is a carboxylic acid and an amine. This is an amino acid. This is glycine. We're going to do that for the next test. All right, and this is an ester. You got your ester group here. This is an amine group. The amines are the most basic organic functional group. And then E, also an amine. So you have all of your amines were NH2s. Every one of these amines was NH2 and primary. And this amide given in part A, also an NH2, is a primary amide. All right, so here's your C double bond O with an H. That's your aldehyde functional group. So, of course, ketones have a C double bond O, but it doesn't have the H. It's got 2 carbon groups. Esters also have a C double bond O, but the other side is an OR, not an H. Which of the following? Okay, when can you have cis and trans? All right. So on the first one here, you've got 2 H's, so you cannot have cis and trans. Here you got a methyl and a hydrogen on that side. Here you got a hydrogen and a chlorine. Yes, number 2 can go cis and trans. For number 3, you've got an H and a Cl on one side, H and a Br on the other side. Yes, those are different on both sides. And so 2 and 3 can both give cis and trans. All right, propene, addition of HCl. Now we are doing a addition reaction, but the addition reaction we did before was with BR-BR, which is adding the same thing to both sides. This time we're adding HCl to propene. So now you have to know Markovnikov's rule, which says when you are adding a compound to a alkene, you always put the H on the side with the most H's, and the other is going to go to the other side. And so here, this carbon has two H's. This carbon has one H and a CH3. That's one H and a CH3. Two H's is more than one H. And so when you add it, you're going to have CH3 now. Now a single bond, you're going to have your CH or Cl is going here, and CH3. So you have a 2-chloropropane. All right, they didn't have you name it. They just gave the structure, which is letter D here. All right, for 18, which of the following reactions is a substitution reaction? Aromatic hydrocarbons undergo substitution reactions. A is a substitution reaction. So you have to know aromatic hydrocarbons, benzene rings, will undergo substitution. Part B, you got an alkene. Alkene is going to do an addition reaction. In this case, each side of this double bond would get an H. Your alkynes will also do addition reactions. So they have a pi bond just like an alkene. They do exactly the same thing as an alkene. They will add the bromines. Now they have two pi bonds, and so we're going to add two bromines. So Br and Br, and then Br, Br for the other double bond. And this bromine addition reaction, a Br and a Br. Part E, it's going to do Markovnikov, except this side has two H's and that side has two H's, so it doesn't matter. So one side gets an H, one side gets a Br. Since both carbons have two H's, it doesn't matter which side you put it on. It will go on both sides. All right, the compound butane and 2-methylpropane. So if we write butane and 2-methylpropane, all right, so when we write butane and 2-methylpropane, these have the same molecular formula, C4H10, C4H10. All right, and so they are structural isomers, so they differ in their structure. All right, geometric isomers, those are cis and trans. Functional isomers, they're just different isomers that have different functional groups, like the alcohol and the ether. Diastereomers, that's the same as a geometric isomer. It is a cis-trans isomer, is a diastereomer. Enantiomer is when you have a chiral carbon and the mirror image, and those are not superimposable, then you have enantiomers. All right, the most characteristic reaction for an alkene, addition reactions, is what an alkene is going to normally do. Characteristics of benzenes, those do substitution reactions. Your alkanes, okay, and it says do not consider their daily combustion, all right, fuels, all right, and so your reaction for alkanes, rather than burning them, what else do they do? And that is a substitution reaction. Which functional group does not contain an oxygen atom? All right, so if you draw an ether, so if you're doing ether, ether is ROR. That's got an oxygen. When you're doing ester, ester is a C double bond O, OR. Well, it's got two oxygens. When you are doing an aldehyde, you have a C double bond O with an H. That definitely has an oxygen. When you're doing an alkene, alkenes simply have a carbon-carbon double bond. There's no oxygen there. An amide has a C double bond O to an N. All right, and so the alkene is the only one that does not have an oxygen atom. All right, which one of the following alcohols is tertiary? So the first one has a carbon with no H's and 3 carbons. So your first one there is tertiary. All right, so A is tertiary. So that's the answer to the question. But if you look at B, that's a CH2OH. That's primary. All right, and then that's B. C has a CHOH. That's secondary. Your D, well, it depends on which one you're looking at. So D, The first alcohol is primary. The second alcohol is secondary. The third alcohol is primary. And then part E, you have a primary alcohol. So the only one that is tertiary is the T-butyl alcohol, letter A. All right, reaction with carboxylic acid reacts with a base. All right, so a carboxylic acid and a base. So you have an acid-base reaction. And so when you have an acid and a base, all right, so that is called, well, let's see what they finished the question. To form of salt and water, acid plus base gives salt and water. That is the classic neutralization reaction. All right, so an acid and a base gives salt and water. That is neutralization. This reaction, where we have an alcohol with a carboxylic acid, so an alcohol, ROH, with a carboxylic acid, HOC double bond OR, what you're going to get here is you're going to lasso water, and you're going to get an ester, and so they give you that structure of the ester. And so when you make an ester, that is called an esterification. So D. All right, so this compound, if you wanted to name it, 1, 2, 3, 4, 5. So that is a pentane. So you have pentane, except you recognize the NH2 as an amine. To name an amine, you drop the E and you add amine. So this is a pentanamine. And then the number for the lowest number for the NH2 group is number 2. All right, and so this is a 2-pentanamine. But this is NH2. NH2 is a primary amine. In order for that to be an amide, you would have to have the nitrogen attached to a C double bond O. All right, so what we do with our alkenes, alkynes, any hydrocarbon is we burn them. All right, and so they want to know here the number of moles of oxygen required for the complete combustion of propene. All right, and so you have your propene, CH2, double bond CH, CH3. All right, so when you're writing this reaction, you can simply do it as the molecular formula. So you can say we have a C3H6 plus O2 yields CO2 plus H2O. You have 3 carbons, you need 3 CO2s. You have 6 hydrogens, you need 3 H2Os. You have 6 oxygens plus 3 oxygens. You have 9 oxygens. So you need 9 halves for the number of oxygens on the left. And 9.5 is 4.5. So 4.5, 9.5 is 4.5. So that is your answer for 28. 29. All of the following compounds exist in 2 or more structural forms, isomers, except. Okay. All right, so you have your C4H10. We already did this one. That is here versus here. You got your C3H7. All right, so there is your C3H7. So that means you're going to have a chlorine, but you could put it as a 1-chloropropane, or you could do it as a 2-chloropropane that has an isomer. Part C, C2H2Cl2. C2H2Cl2. All right, so that means you have to have a double bond. So you could write it this way. You could write it this way. Or you could write it this way. regardless, you can write it definitely more than one way. And so, yes, there are isomers with that molecular formula. All right, so then we have C2HCl3. C2HCl3. And that's it for that one. You cannot do anything else. C3H6. This one's interesting. CH2 double bond, CH, CH3. So many people will pick C3H6 because there is no other alkene that can be written as C3H6. However, there is a cycloalkane that can be written as C3H6. All the following exist in 2 or more except for it. So D is the only one that only has the one possible structure. All right, acid catalyzed hydrolysis of an ester. All right, so hydrolysis means you're going to split it. So basically, it is the reverse reaction of what we did before. So if you remember, take your alcohol and add your carboxylic acid. You lasso your water, you get your ester. Or, of course, you can break your ester into a carboxylic acid and an alcohol. All right, so you would get a carboxylic acid and an alcohol. So C is the answer for that one. The alkanes, these are saturated. Okay, the alkanes are saturated. Saturated is not a choice. Unsaturated would be your alkenes and your alkynes. Alkanes are non-polar. So your alkanes, these are non-polar. If you mix your gasoline with water, you get 2 layers. They do not mix. Gasoline is not soluble in water. Like dissolves like, water is polar, and alkanes are non-polar. Which of the following compounds we expect to be the most soluble in water? All right, so like dissolves like. All right, ethanoic acid. All right, that's going to be a very good choice. CH3 double bond O, OH. You've got an OH, yes. Propanone does not have an OH. That's simply a C double bond O. Ethanal does not have an OH. It's C double bond OH. Ethylene is going to be probably the least unless there's an alkane. So CH2, CH2. And dimethyl ether. I say there's only one that has an OH, like dissolves like. And so water, you're looking for the OH, and that is when like dissolves like. So it is the ethanoic acid, or of course acetic acid, and we know that we have vinegar, which is a 5% acetic acid in water. All right, so all of the following compounds would be expected to be very soluble in water, except, all right, that's a good one. Ethanol is E. That's, of course, soluble in water. Propanol, that's got OH. That's soluble in water. Propanone, it's got a C double bond O. That is good. Chloroethane, not good. So chloroethane does not have an oxygen. Ethylamine. Now, ethylamine doesn't have oxygen either. But when we look at ethylamine, what it does have is hydrogen bonding. All right, and so water has hydrogen bonding, and that's how ethylamine and water are alike. All right, everything else has an O, which makes it more like water. And so the answer here, the one that would not be soluble in water, would be the chloroethane. There's no hydrogen bonding, and there's no oxygen. The equation which represents a substitution reaction. All right, so the first one's combustion. The second one's combustion. The third one is an addition reaction. So when you see C2H4, there's a double bond there, and then the chlorine was put on each side. That is an addition reaction. Here, what we've done is we have our alkane that has done a substitution reaction. So one of these H's is now converted to a chlorine. So that's CH3CH3. And now it's CH3CH2Cl with HCl. So D is your substitution. E is your esterification. That's your carboxylic acid with your alcohol giving your ester. Which compound can exist as cis-trans isomers? 1-butene, no, because you have two H's on the first carbon. All right, and so as soon as you start it, you have CH2 and double bond, and you can say no cis-trans. 1,1-dibromo. What the heck? There's no such thing as methane. All right, so anyway, that compound doesn't exist. All right, 1,2-dibromoethene. Okay, that exists. 1,2-dibromoethene. All right, so when you draw 1,2-dibromoethene, now you see that you can have cis as written, or of course you could have trans. All right, and so that is your answer. If you do a 1,1,2 tribromoethene, that means you have two bromines on the first one. No. 1 bromo, 1 chloroethene, that means that the second carbon has two H's. No cis-trans isomers for that. All right, which of the following is an aldehyde? First one's a ketone, second one's the aldehyde. So that's aldehyde. Then you got your ether, you got your carboxylic acid, and you got your alcohol. Number are we on? 38, molecule with this structural formula. All right, so you got an OH, that's an alcohol. You got an NH2, that's an amine. You got your C double bond O, that is a ketone. The correct name for this one, all right, so when you name an ester, you name the group coming off the O first, that is ethyl, and then you name the rest of it as a deprotonated carboxylic acid. And so that is a 3-carbon, which would be propane, that would be propanoic acid. Drop the ic acid and you add 8, that is propanoate, so that is ethyl propanoate. Which of the following is a secondary alcohol? The first one is an ether, not an alcohol at all. B, you have a CH2OH, that's primary. C, you have a CHOH, that is a secondary, which is the answer to the question. D, you have a C with no H's and an OH, that is a tertiary. And E, same thing, you got a C with no H's and another tertiary. Geometric isomers are found in alkenes. Geometric isomers are your cis-trans isomers. Oxidation product of a secondary alcohol. When you oxidize a secondary alcohol, you get a ketone. So if you have a secondary alcohol, you get a ketone. Primary alcohol, you get an aldehyde. You're going to get a ketone when you oxidize it. If it were a primary alcohol and you oxidize it, you get an aldehyde, which can continue to be oxidized to give a carboxylic acid. All right. All right, and so that's the next one. Okay, so secondary gives a ketone. Primary gives aldehyde. If aldehyde is not a choice, which it is not, then carboxylic acid. Or if they're both there, it would be both a aldehyde and a carboxylic acid. All right, which of the following molecules? No, okay. Which class of compound is a base? All right, so again, you have to know your amines, C, Your amine is the most basic. Your acid is, of course, the most acidic. Which of the following have the shortest carbon-carbon bond? You're looking for the alkyne. A triple bond is as short as it can get. All right, and so that's an alkane, that's an alkene, that's an alkyne. C is the shortest. Which of the following has the longest carbon to oxygen bond? Now you're looking for a single bond. Here's a double bond. There is a double bond. That is your aldehyde. There's a double bond. That is that doesn't seem right, but okay. And that's a single bond. So here's your single bond. That's going to be the longest bond. 47. Longest carbon chain is going to be 5. 1, 2, 3, 4, 5. So you've got, you can go either way, and you're going to go the way that gives you a 2,3 dimethyl propane. Chemical structure. So 48 is not a question. Oh, no, there it is. All right, so that is orthodimethylbenzene. And you just count the carbons and hydrogens. Functional group of an alkyne is a triple bond. You have a sigma and 2 pi. The functional group of an alkene is a sigma and 1 pi. And that is the end of all 50 of those problems.